Okay, hello guys. Happy Sunday. Welcome back to our seminar. Uh, it's a weird to have a class on Sunday, isn't it? Yes, Rebecca, hello. So we are just doing a revision for today. So I hope this thing will help you in your coming exam. All right. So as I know, your exam is coming like should be the mid or hopefully it's the end of May, should be around that time. All right, so quick thing, if you haven't received the notes, it's probably on the way. All right, because of the riot thing, that's why the delivery is kind of slow these few days, so you might just have to wait for a bit until the thing comes back. Yes, thanks for the compliment. Wait, are you Yashvini? Is your why is your name like that? what's with the gibberish? Okay, anyway, so we are revising for our chapter 1 and chapter 2 today, because I believe when I taught this thing, it was around January or February. Okay, that time you guys are still in holiday. Okay, so we will do a quick revision on this today. All right, anyway, so let's go to chapter 1 first. All right, we will start with chapter 1. Today's lesson will be a bit rushed, guys. I will kind of speed things up because there's a lot of things I need to talk about. So I will need to, speed things up. So I don't think I'm taking any break today. I'll just straight away go for everything. So if you really need me to stop, you let me know a bit. So anyway, our chapter 1 is stimuli and responses. So as you know, what is this? Your stimuli and responses actually has a pathway. Okay, if you still remember what is your stimuli, rangsangan. Okay, who detects your stimuli? Your receptor. And your receptor will send a signal to your coordination center, which is your brain or your spinal cord, your otak or your saraf tunjang. Yes, Kajun, hello. Good evening. And then your brain will send another signal to your effector, which is your muscle, and your muscle will produce a response. All right. So this pathway of 5, you have to know them. So which is your, again, stimuli, rangsangan, receptor, brain or spinal cord, otak or saraf tunjang, and your effector, and then your response, gerak balas. All right, so this would be your human nervous system. So what's their function? To detect stimuli, to send information in the form of impulse. Impulse is the signal. So interpret the impulse and produce appropriate response. So this part, what is your central nervous system? What is your peripheral nervous system? This part is not too important. I mean, you can memorize them, but it's not really important. Central nervous system is basically the headquarter of your nervous system, and peripheral is the side of your nervous system. All right, so this thing is very important. This is not so important. If you break one of the nerve in your peripheral nervous system, you are still okay. But if you break a nerve in your central nervous system, wow, that's a very serious matter because you could be paralyzed for life. All right, so anyway, let's go to our voluntary and involuntary action. So what is this? Voluntary is tindakan terkawal, things that you can control. You're doing it consciously. Involuntary is tindakan tak terkawal, something that you cannot control. You are doing it without your consciousness. So voluntary action is controlled by your brain, okay, which is your main brain here. And your pathway, okay, this one you know, like I told you already, stimulus, your receptor. You have to learn the pathway, your brain, nerve impulse, this is just the signal, and then your effector and then your response. So for your involuntary action, there's actually 2 parts. One part is handled by your medulla oblongata. What is this? This is actually the top part of your spinal cord. Okay, if you look at your spinal cord, okay, this long tail here is called a spinal cord. The top part near the brain is called your medulla oblongata. This thing, they will control all the small stuff like heartbeat, breathing, coughing, sneezing, and so on. But your spinal cord, they only control one thing, which is your reflex. Okay, you know it's reflex? When someone tickles you, you turn around and slap them. That's the reflex. Things you cannot control. things that pulls you out of danger. So that's your reflex. All right, so like you withdraw your hand when you touch something hot, okay, when you step on something sharp. So this is the same thing, stimulus, receptor, spinal cord. This thing doesn't go to your brain, it goes to your spinal cord, and then it goes to the effector and the response. So again, that 5 thing, the pathway, the 5 pathway you have to know. Okay, this is the important one. All right, so the importance of human nervous system, you can just read this yourself. This is not really important. I'm not going to talk about this. All right, so let's go to our eye, shall we? Okay, the first part of our senses. Okay, let's talk about our eyes. All right, so if you say, sir, this is so damn difficult to memorize, there are like 14 parts here. Don't scared, because you don't need to memorize all of it. You just need to memorize a certain part. Okay, so if you really want to, you memorize the parts that lights will go through. Okay, the parts that light will go through. So like for example, light will first pass through the first layer called your cornea. Okay, your cornea. And then next, they will pass through this bag of water here, which is called aqueous humor. And then they will pass through this hole here, called your pupil. And they will pass through this transparent thing called your lens. Next, they will pass through this big bag of water here called vitreous humor. And last, they will hit your retina, which is where all your receptors are located at. So this retina here, which is the inner layer here, it has a lot of receptor that is able to detect light. So that's your retina. So these 6 parts, I would say they are the most important because light passes through them. This is how you see. All right. So, and as for these 4, your cornea, your lens, your aqueous humor, and your vitreous humor, they have the same function. You see, cornea is to focus light. Aqueous humor is to focus light. Eye lens, focus light also. Vitreous humor, focus light. You see, these 4, they are to focus light onto your retina. And then your retina will detect your light because it contains photoreceptor, which is the receptor to detect light. And then, of course, they will send a signal through your optic nerve, which is sent to your brain, and your brain will interpret the message. Okay, mentafsirkan impulse saraf, see whether this is something you like or something you don't like. So that's what your brain will do. So pupil is the hole. Pupil is the lubang. Okay, this lubang here, that's the pupil. So this pupil, okay, then what about other parts? You must say, sir, what about all these? Should we memorize this? If you have the time, then yeah, sure, go ahead. But if you don't have the time, then I wouldn't say it's very important. Like this conjunctiva, I don't really memorize this. I don't care. Iris is to control the pupil. If you look at Mat Salleh, if you look at Western people, they have actually blue color iris. That's the part that looks blue, that's the iris. And then your suspensory ligament and your ciliary muscle, the ligament is to hold the lens. The muscle is to change the lens, is to pull and pull the lens, to move the lens basically. Okay, if you are looking at something close, they will make your lens thicker. If you are looking at something far, they will make your lens thinner. So nothing much to say here. Sclera is the outside white layer. Choroid is the part that gives nutrient to your eyes, the black color middle layer, which is this middle layer here. It's supposed to be black. And then your blind spot, as the name says, is the spot that is without any receptor. And yellow spot, that's the most sensitive spot with the most receptor. So they're the reverse. Yellow spot, very sensitive. Blind spot, not sensitive at all. So that's all. So the only few parts that you should focus on are these, because light pass through them. They are quite important. All right, so that's all. So inside your retina, you have your rod cell and your cone cell. If I'm not mistaken, rod cell is to see during the dark, and your cone cell is to see during bright, and they can see color. One is sensitive towards color, one is sensitive towards light. Okay, so not really important. And then the mechanism of sight, how do you see things? Light, they enter through the cornea, aqueous humor. This is called Gerlum IA in BM. Eye lens, Kanta mater, vitreous humor, Gerlum acha. Okay, and reach the retina. And then your retina, the object is smaller and inverted. Okay, you learn this in Form 1, Song Sang. And then they will stimulate your receptor to produce nerve impulse, send it to the brain. The brain interprets the nerve impulse So, and then your brain will turn this image upright. So whatever image you see, they are not reversed. Your brain actually turns them upside down again. That's all lah. Really simple. Okay, your eye is really simple. Okay, so how about ear? This one, I'm afraid you have to memorize most of it. All right, so your ear has the outer ear, your middle ear, and your inner ear. Okay, so your outer ear has only two parts, which is the earlobe. This part here, which is to collect sound, and then your ear canal. Okay, this is called Salo-Telinga, which is this part lah. Then when you dig your ear, you are digging this part lah. Okay, all your earwax, they are stuck here, so you're digging here lor. And then when it enters your middle ear, this is where you hit your eardrum. Right, so as the name say, it functions like a drum. When you hit them, they vibrate. Okay, when they vibrate, they will send the vibration to the next part, which is the bones here. Okay, these bones they are called ossicle. Okay, we call it tulang ossicle in BM. So why do you need these three bones? They are very important because they amplify your sound. Membesarkan suara. Okay, you know what is amplify? Amplify means to make your sound louder. When you talk on a mic, when you speak to a mic, okay, a microphone, your voice is okay. But when it comes out from the speaker, it's really loud. Why? Because in that speaker, it has something called an amplifier. Have you heard of this thing? Have you heard of this thing? Your car also has this thing, what? Okay, your car radio is an amplifier. They amplify the sound so they can hear it. So same thing, so they amplify these three bones, they will amplify your sound. Okay, why do this? Because you see, if the sound we hear is really soft, if they pass through all these layers, by the time they reach our brain, the sound will be so soft we will hear nothing. So this thing is to amplify the sound, and then they will pass it through something called an oval window, jendela bujur. This is just a hole, nothing to say here. Okay, they just pass this thing to the cochlea. So next, the inner ear, the most important part would be your cochlea. What is this? This is the part that changes your sound into nerve impulse. Okay, they are the translator. They translate your sound signal into an electric signal. So inside here is basically water, liquid. So they have hair. So when this liquid vibrate, the hair will change this thing into a sound signal, into a nerve impulse, and then they will send it through the auditory nerve to your brain. And then your brain will recognize the sound. Okay, so that's called your auditory nerve. Okay, what about these two parts here? Can you see these two green highlighted parts? Your eustachian tube and your semicircular canal. They are not involved in hearing. They have nothing to do with hearing. Your eustachian tube here is to control ear pressure. Okay, to involve in your ear pressure. That's why when your plane, if you're on a plane, when the plane takes off, you feel there's a pain in your ear until you swallow your saliva, then your ear goes pop, and then it's normal again. Because you are the air pressure is different. And then your semicircular canal is to detect the position of your head. This is to help you balance. That's all. This is to help you balance. You are not doing any hearing with your semicircular canal. Okay, this is called Salo Separuh Bulat, I think, in BM. All right, so this is your ear. Really nothing much to see here, really simple. So the pathway is like this. Okay, your sound hits your earlobe. Okay, it passes through the ear canal, hits the eardrum, amplified by the ossicle, passes through the oval window, okay, into your cochlea. Cochlea change this thing into nerve impulse, send it via your auditory nerve to your brain. That's it. Okay, that's it. Really, really simple. Okay, so this is the pathway lah. I'll leave it up to you to read. Next, nose, your sense of smell. Okay, your nose and your tongue. Okay, I have to explain this together because they kind of work together. Your sense of smell and your sense of taste, they work together. You can't live without one another. Because if your sense of smell is not working, your sense of taste, they suck. Okay, eating just tastes bad and nothing. Okay, bland because your sense of smell is not working. All right, so listen, your sense of smell and your sense of taste, your nose and your tongue, they need to be wet. They cannot be dry. Okay, dry doesn't work. So this is why your nose, your nose has something called smell receptor. They are wet by this thing called mucus, which is that sticky thing when you have flu, you have mucus, right? So same thing, your tongue is wet by your saliva. So you see, your tongue is constantly wet. Your smell receptor, okay, on your tongue, there's something called taste bud. They are constantly wet. And then your smell receptor, they are also constantly wet. They are constantly in this mucus and your saliva and so on. All right. So they basically detect the same thing. They detect chemical substance. All right. Smell and taste is a chemical substance. So when chemical substance they dissolve in mucus, they will stimulate your receptor, your smell receptor, and they will produce nerve impulse. All right. Same goes to tasting. When you eat something, the chemical substance dissolve in your saliva, so they will stimulate your taste bud, and then they will stimulate your taste receptor. They will change it to nerve impulse. So tongue and nose, same thing. You need something wet, and the chemical substance need to dissolve in that thing, in that wet thing, mucus and saliva. Only they can stimulate the receptor. So they work the same way. All right. So it's not written here, but this one I have to tell you. Why do we not? I think this one, if you attended my January class, I've told you this already. Why do food taste bad when you have a flu? Because when you have flu, you have all these mucus stuck in your nose. Okay, so if you are full of mucus here, the smell can only dissolve outside here. They cannot reach your smell receptor. So if your smell cannot reach your smell receptor, they cannot stimulate your smell. Your sense of smell is not working. Okay, so since your sense of smell is not working, your sense of taste becomes very limited. Okay, if you cannot smell your food, you cannot really taste your food because of the too much mucus here. Yeah, easy, all right. So anyway, about your tongue, there's actually one more thing to memorize, which is the part of your tongue that is sensitive. So the front part of your tongue is sensitive to sweet. Okay, that's why you lick your lollipop. Lollipop is sweet, right? How do I memorize this? Lollipop is sweet, right? You lick your lollipop with the front of your tongue. And that's why it's sweet here. And then the opposite of front is back. So the opposite of sweet is bitter lah. So behind is bitter. Sour is at the side, because when you eat something sour, it feels painful here. Right? When you eat something, if you're hungry and if you eat something really sour, it feels very sour here, very painful here. So sour is at the side, lor. And then salty is around here lah. Then what is umami? Umami is the whole tongue. Okay, like I told you before, umami is the sense of taste that when you stimulate this thing, every taste becomes better. When you stimulate your umami, salty becomes more salty, sweet becomes sweeter, sour becomes more sour, bitter becomes more bitter. So what stimulates your umami? There's a chemical substance called glutamate. Okay, glutamate. Where can you find glutamate? You can find glutamate in tomatoes. You can find it in anchovies, ikan bilis. You can also find this in MSG. You know, it's MSG. In Mandarin, you call it 味精. Okay, you know, Ajinomoto, that's the thing lah. So if you put umami in your food, it's going to taste so much better because it enhances all other tastes. So that's a good thing. All right. So as you can see, the sense of smell is related to sense of taste. Okay, it's used to recognize food. All right, really easy. All right, so next is your skin. Your skin has 3 layers, by the way. You have the uppermost layer called the epidermis, the middle layer called the dermis, and the bottom layer called your fats, okay, fatty layer. So you have 5 types of receptors here. Okay, the top receptor is your pain receptor, followed by your touch. Okay, this diagram sucks lah. Later in your exercise, I'll give you another diagram, because you see can you see your heat and your touch and your cold? All 3 receptors, they look the same. Glutamate. It's called glutamate. Okay, glutamate. This thing, you go and search for this. MSG stands for monosodium glutamate. Okay, which is the thing that makes your food taste better lah. Okay, so anyway, these 3 things can you see they're actually the same shape? So that's why I hate this diagram. This diagram sucks lah, because they are at the same level, they are at the same shape. They are not like that. And of course, the last one is your pressure receptor. They detect pressure lah, and as you know. So I'll talk more about this in our exercise later, don't worry. So next, sensitivity of skin. What makes your skin sensitive or not? It depends on number 1, your number of receptor. Number 2, the thickness of your skin epidermis. So the more receptors you have, the thinner your skin is, the more sensitive they are. For example, your face. Okay, your face has a lot of receptor and it has very thin skin. Whereas for the reverse, your shoulder here, it has very little receptors and very thick skin. That's why you inject here, you don't inject here. I mean, you can inject here, but it's gonna be awful. Okay. So anyway, so you can read this you see a lot of receptors and epidermis is thin, like your tip of the finger, tongue, nose, and lips, very sensitive. These parts are not sensitive. Okay, elbow, knee, sole, and the back of your body. So where do we apply this? Okay, blind men use the fingertip to read braille. Okay, injections given at the upper arm of your buttock. Okay, test the temperature of milk by placing on the back of the hand, or you can put it on your wrist. This part is very sensitive to temperature. That's why mothers, they will use this part to detect whether the milk is too hot or not. Okay, you know this lah. So anyway, next one, limitation of hearing. This part, you actually learn it in your Form 2 already, so I'm not going to talk too much about this. Your frequency of hearing goes from 20 to 20,000. This is your range of hearing. And as you age, this thing gets narrower and narrower because your eardrum gets more and more loose. All right. When you get old, every part starts to get loose, right? You get saggy skin, saggy here, saggy muscle, saggy everywhere. So even your eardrum gets saggy, so they are not so sensitive already. So that's why the thing become worse lah. So as you get older, frequency of this range gets narrower because the eardrum becomes less elastic. So this device used to overcome, okay, read this yourself. So defects of hearing, if you damage your outer and the middle ear, okay, you just clear the foreign object. Eardrum or ossicle, you can go for surgery. If your cochlea is damaged, you need an implant. Okay, have you heard of a hearing aid? Okay, you see some people, they put, there's a piece of thing attached at the back of their ear. That's the hearing aid. So usually it means something is wrong with their cochlea, so they need to they need to put an extra amplifier here to amplify the sound because something is wrong. All right, so but if you damage your nerve, your auditory nerve, sorry, this cannot be corrected. Any damage to any nerves, there's no way back. It's forever done. Okay, nerves, they don't regrow. All right, so limitations of sight, you have your optical illusion. Okay, that's why you see certain things appear in a very funny way. Like I told you, that dress, okay, it's either white or gold or blue and black. I still see white and gold. You know that dress thing? It was like the middle of argument everywhere. All right, that's an optical illusion. We all see things differently. All right, and of course your blind spot, as the name says, if your object falls onto the blind spot, you don't see anything lah. All right, so limitation of sight, again, read this yourself. Yes, the blue and pink shoes, yes, exactly. I still see blue. I still see gray and blue. Okay, I don't know how the hell do y'all see pink. Same goes to the dress lah. Okay, I swear I see white and gold. How can y'all see blue and black? I don't know, maybe my eyes got problem. Okay, anyway, so next is your short-sightedness, long-sightedness, and astigmatism. Funny thing, this one in BM is called Rabun Jauh because BM is reversed. Okay, Rabun Jauh, and long-sightedness is called Rabun Dekat. So you just need to memorize one side, guys. Just memorize one side because the other side is the total opposite. So when you have short-sightedness, that means your image is short. Can you see? Instead of going all the way to your retina, now your image is formed in front, short. That's why it's called short-sightedness. So what causes this? Number one, it can be your eyeballs being too long, or you have your lens being too thick. Like I said, if you look at close objects, if you look at near objects, your lens needs to be thick. But if it is too thick, then you see close things very clear, but far things you cannot see. So that's your short-sightedness lah. So it can be either one. So what can you do? You can wear a concave lens. You can correct this thing using a concave lens. Kanta Jekung. Okay, Kanta Jekung. And of course, long-sightedness is the reverse. It's your lens being too thin or your eyeball being too short. Because you have long-sightedness, you see, your image is too long. It's behind your eyeball. So how do you correct this? You use something called a convex lens, Kanta Jembung. All right, so you just memorize one side lah. I believe most of you have short-sightedness lah. I've not really heard of long-sightedness before. All right, so you might say, sir, what about Rabun Tua? If I'm old, if let's say your parents what do they have? If you are old, you have both. You cannot see close things very close. You cannot see far things very far. So being old is a combination of both. Okay, because your eye just gets worse as you age. It's a thing. All right, so astigmatism, this is called 散光 in Mandarin, which is you have your light scattering everywhere in your eyes. So this is usually caused by the curvature of cornea. Instead of your cornea being round and nice like this, now it has an uneven angle here. Okay, your cornea just being retarded already lah. So what do? You wear something called cylindrical lens, Kanta cylinder. All right, so what about the long-term solution to fix all these things? Guys, just go for laser lah. Hey, you know laser surgery, how do they work? They will use that laser and slowly scrape off layers and layers of cornea so that your cornea becomes round and nice again. Yeah, it sounds scary, but they do it using laser. So it's really, really accurate and precise, okay? So if you have the money, go for it. If you are sick of wearing glasses, okay, anyway, so for our plants, we have something called tropism. Okay, tropism is the response. All right, so we have 4 types of response, 5 in fact. If I respond towards sunlight, it's called phototropism because photo is light. And then you have geotropism towards gravity, hydrotropism towards water, thigmotropism towards touch. All right, and of course, nastic movement. This is something similar to thigmo. It's just that this is fast. Okay, thigmo is slow. All right, so thigmo mostly happens in what do we call tendrils okay, the climbing, you know, cucumber, those climbing plants. So thigmo lah. Okay, as you see, they are very slow. Okay, for a cucumber to fully entwine a stick, it will take them weeks. Okay, but for nesting movement, it's a few seconds thing. For example, your mimosa plant. You know, mimosa plant, when you touch that thing, the leaf will close. That's immediate and fast. I think your mimosa. That's a nesting movement. All right. So when you talk about tropism, do remember you must write either positive or negative. You have to. Positive means you're growing towards the thing. Negative means you're growing away. So for example, if I have let's talk about phototropism. That means the response towards light. My shoot will always be positive phototropism because shoot will always grow towards light, right? Whereas your root, they are growing away because they grow downward. So it's a negative phototropism. So you need to say tropism whether it's negative or positive. All right. So for geo and hydro, it's the same thing. For root, they grow towards gravity and water. So this is positive geo and positive hydro. And as for shoot, they are growing away from it. So it's either negative geo or negative hydro. Really easy stuff. Okay, this part is really, really easy. All right. So the rest of it is just experiment. If you want, you can read this yourself. I'm not going to repeat this thing. Okay, it's really, really easy. And of course, the next one, the last one I would guess, this is our stereo and mono. All right, so stereo is for predator. Okay, mono is for prey. So stereo means using the overlap of 2 eyes to see something. Mono means you use each eye to see each thing. So what are the advantage and disadvantage? For stereo, okay, for stereo, they are accurate because you use both eyes, but the field of vision is very narrow. You only see things like this, right? Whereas for monocular, for mono, they are the opposite. They have wide field, but they are less accurate. So it's like a give and take. See which one you want. Because they all function differently. If you are a predator, you are trying to catch a prey as accurate as possible. So field of vision doesn't matter to you. All right. All you want is being accurate. You want to catch something accurately. Whereas if you are a prey, if you are a mouse, your job is to run. Run. You don't care. Okay. If you let's say you are a goat, your job is to eat grass. You need so accurate to eat grass for what? So you have a wide field of vision, okay, but they're less accurate. The point is to detect predator and run. End of story. Okay, so really simple. So stereophonic hearing is by using 2 sides of our ear to hear. Okay, there's no monophonic hearing, no such thing. So Hearing frequency of animals. Okay, this one you learned this in Form 2 already. Sensory organs on animal. This one read this yourself lah. This part is not coming out in exam, so please don't focus. Okay, I'm not saying 100% won't come out lah, but it's very, very rare this thing will come out. So okay, kindly don't focus. This is not important at all. All right, so that would be it for our chapter 1. All right, next we'll go into chapter 2. Okay, let's go to exercise first. Let's do some exercise for our chapter 1 and 2. Okay, for the objective questions, A, B, C, I'm not going to go into it. You can do this yourself. The answer, I'll put it in Google Classroom. Okay, please check there next time. So I'm not going to do A, B, C. Okay, let's go for page 4. Let's start with section B and C. All right, so question 1. Label S and T. So S would be your retina, and T would be your pupil. This pointing is a bit unclear lah. They should point to this hole instead of this thing, because this thing is actually your lens. Anyway, no matter. So where's a blind spot? Whatever your blind spot is here. Where they need to turn into your optic nerve. This is your blind spot. All right, so if image falls onto this point, you will see nothing. All right, so anyway, moving on. So B shows the structure of a human eye. Complete the following flow chart. So you start with your cornea, which is here, and then your aqueous humor gallum eye, which is this back here, followed by your pupil. Okay, BM is the same spelling, pupil. All right, and then your lens. And then this part is called your vitreous humor. Okay, gallum ocha. And then your retina, which is here. All right, and then send to your optic nerve, and that's your brain. So like I said, memorize the pathway would be more important than you memorizing all the parts. Yes, I know eyes have like 14 parts. Should you memorize all of it? I don't think it's needed. All right, just memorize the pathway will do. Unless you might say, sir, I have so much time, I have nothing else to study. Then yes, go ahead, memorize the rest of it. So the first exam, you might need to memorize all, because first exam, they have nothing to ask. So maybe they will go a little bit more detail about the questions. But as you go to your mid-year and your year-end exam, your PT3, I don't think they will ask too much about the eyes. So you can kind of no need to focus there. Okay, I'm not saying it's not coming out. I'm just saying that the chance is really low. All right, so next, number 2. X is your stereo and Y is your mono. What is astigmatism even doing here? So mark for the correct answer. What is bird X? Okay, bird X is this stereo. So that's your owl. This is the only predator here. Don't you find owls cute? You see, stereo animals, they look cute. All right, stereo animals, they look cute. Like, don't you find cats cute? Don't you find dogs cute? Don't you find humans cute? Depends on which human lah, because we are all stereo. And if you look at mono animals, they look kind of dumb. Don't you find horses, they look dumb? Cows, they look dumb. Goats, lambs, chicken, pigeons, they just look kind of dumb because their eyes are on the side. Okay, that's why. Because they are dumb. Their job is to run. All right, so number 2, what is the advantage of vision of bird Y? Okay, so that's your mono. So what's the advantage of mono? Field of vision is narrow. No, it should be wide. Okay, they can see a lot of things. So able to estimate distance accurately. No, these 2, they are for stereo. All right, helps bird Y to detect its prey. Yes, okay, they can see prey really easily. Pigeon looks stupidly cute. They're annoying though. Hey, guys, do you know pigeons, they spread a lot of disease? How do I know? Because my outside here has a lot of pigeons. Okay, because I live in a apartment, and I don't know lah. My place here has a lot of pigeons lah. I just find them dirty. All right, they shit all over the cars and whatnot. I just find them annoying. Okay, anyway, so number 3, the tongue is a sensory organ that gives a sense of taste. So label your region here. So S would be salty. Okay, U would be bitter. Right? So your sweet is a T, sour is a V. The rest of it is umami. The whole tongue is umami. All right. So why do we call it umami? Because it's discovered by the Japanese. All right, guys, eating umami, eating MSG doesn't kill you. Okay, MSG doesn't kill you. Salt kills you. All right, so don't think that, oh, I'm sure your mom tells you this, oh, don't eat outside. Outside got a lot of weighting, got a lot of MSG, you're going to die. You know who eats the most MSG? The Japanese. The Japanese, they put MSG in every freaking thing. Their soy sauce, sushi also got. Their miso soup also got. Ramen, udon, everything they put MSG. Hey, they are the longest living humans in the world. Average age 85, you know. Life expectancy in Japan is 85. Okay, so if you say MSG is so unhealthy, why are they living such a long age? Because MSG is not the problem. The problem is salt. Don't get confused there. All right, so B, write true or false for the following statement. Food that cannot dissolve in the saliva cannot be detected by taste receptor. Yes. Okay, everything needs to dissolve in your saliva. So without the sense of smell, food tastes great. No. When you have flu, your taste sucks. Okay, it just tastes bland. You just don't feel like eating anything. All right. Anyway, so I hope I'm not going too fast, guys. If you need me to slow down, you let me know. Okay, I'm just trying to be as fast as I can. So this is injection. So this would be your thick epidermis, so you don't feel pain. Feeling the milk on your wrist, that would be large amount of receptor because it's sensitive. Touching hot water, large number of receptors as well. All right, next. So this person has a sight problem. So the man uses smell while walking. No. False. The man uses hearing when walking. Yes, true. And the man uses touch when walking. True. So for blind people, their sense of touch and sense of hearing is stronger than us because they uses those two senses a lot compared to their sight. Okay? They don't really use their sight, so that's why they're more sensitive. All right, so anyway, moving on, let's go to number 5. So classify the following into 2 groups. So voluntary action is something that you can control. That would be your cycling and swimming. Right, so secretion of saliva and sneezing will be your involuntary, things you cannot control. Okay, so B, diagram below shows the sequence of impulse transmission in involuntary action. So P would be your receptor. Q would be your effector. Receptor and effector. So a nerve impulse is here. Okay, this middle arrows here, they are all nerve impulse. Okay, so easy. Next, what is the action shown in the above diagram? What is the importance in our daily life? Okay, so when you touch something and you withdraw your hand, this is called reflex. Okay, tindakan reflex. So what's the importance of reflex? This is to protect us from danger. Okay, melindungi kita dari kebahayaan. Right, so when you touch something, can you write involuntary action? I'm afraid your teacher might give you wrong because involuntary action could be sneezing and coughing as well. So that's the I don't know about your teacher, but I will give you wrong because this is reflex. Okay, reflex. That's the more important one. So like I said, reflex is to protect you from danger. All right, you cannot control this thing. If you are a very jittery person, if I tickle you, you're going to turn around and slap me. Because that's your reflex. You're just protecting yourself, okay? Nothing wrong with you. Okay, so D, what is the person's reaction in the above diagram? Why does the person react this way? All right, so what is the reaction? Okay, he withdraw his hand from the fire. Okay, menarik tangan dari api. So why is he doing this way? To prevent injury, okay, to his hand. Okay, untuk mengelakkan kecederaan. Okay, to stop injury. All right, so reflex is something that is stopping you from pain. Guys, pain is a sensation that humans hate. Your body hates pain. All right, so if you touch a certain animal and you make them painful, a wild animal, they are going to scratch you or they are going to harm you. Because you cause them pain, they are trying to protect themselves. Okay, how about people with pain kings? Yes, really. Why are you asking that? Okay, so you might say, sir, why some people they enjoy pain leh? That is another thing. that is what we call an acquired taste. I don't know. Okay, you don't ask me, sir, why some people they enjoy BDSM leh? So I won't go there. Okay. let's keep our lesson proper. Okay, can I have the recordings? Oh, okay, sure. Where do you have to go? Make sure you watch it. Okay, I'll send it to you. Okay, so E, state one other example of involuntary action. Okay, controlled by the medulla oblongata. So it could be your sneezing. Okay, sneezing, coughing, whatever lah. And then what is controlled by your spinal cord? There's only one thing, which is your reflex. Okay, your spinal cord only controls reflex because that's the most important thing. You have a whole tail controlling your whole reflex because that's the basic instinct that you need. Okay, what is more important than withdrawing yourself from danger? Am I right? So that's the most important thing. Okay, so moving on. 4 parts of the eyes are involved in focusing light onto retina. So that will be your cornea, your aqueous humor. I'm just going to write short form. Your lens, eye lens, and your vitreous humor. Okay, cornea, this is called gerlum eye. This is called gerlum acar. This is your kanta. Oh my God, that's such a short form. Okay, so state one difference between yellow spot and blind spot. I'm just going to write it here. This is sensitive towards light. This is not sensitive. Okay, peka dan tidak peka. Okay lah, I'm really lazy lah. It's a Sunday. I don't want to stress my writing muscle. Okay, so I'm just gonna keep everything short. All right, so anyway, let's go to the next question. So complete the diagram to show how light enters the eye and draw the image on the retina. So that's a good question. So your light will become like this. Okay, and then you'll see a candle here. Okay, and then your candle is reversed. Okay, because it's formed in your eyes like reverse, but your head will just turn this thing back upside down again. So you see your image is in a proper way lah. So stage 3 characteristic. Ooh, this one is in the form 1 actually. Okay, do you still remember? Your form 1, when you have your image in reverse, this is called inverted. Okay, songsang. And since this thing is becoming smaller, so this is called diminished. Okay, mengecil. And since this thing is on the opposite side, this is called real. Nyata. Because if they are on the same side, this is called virtual. Okay, maya. You remember this one? You learned it in form 1. your optics chapter, which is Form 1, Chapter 7, Chapter 8. Yeah, that chapter. So E, what will happen to the structure F when someone look at distance object and look at nearby object? Where is F? There's no F here. Okay, I think F refers to the lens lah. I'm just thinking lah. So when someone look at distant object and nearby object, so when you look at far object, your lens become thin. And then when you look at near object, your lens will become thick again. So what will happen? So they will go from thin to thick. Right? So your lens will go from thin like this, and then it will thicken because you're trying to see something close. Like I said, when you see something close, your lens need to be thick. Okay, dari nipis ke tebal. Okay, moving on. So the difference in the size of pupil, when your pupil decrease like this, that means this fella is in a very bright room. Whereas B, this person is in a very dark room. Right? Because when you're in a dark room, you try to open your iris more, your pupil more, so that you can absorb more light, so that you can see more things. So state the different size, the difference of size of pupil. Explain which light is under low light condition. So let's explain the pupil first. So which pupil is smaller? So the pupil of A is smaller than B. Okay, I just write A is smaller than B lah. I'm just lazy like that. So explain which eye is under low light condition. That would be your B. So explain why is it under dark condition. Okay, because the pupil becomes bigger to allow more light to enter the eye. Okay, pupil menjadi lebih besar untuk membenarkan lebih cahaya memasuki mata. That's why you open your eyes big. All right, so this is why there's a reason they say do not look at a bright screen in a dark room. Because when you're in a dark room, your eyes become like this. So immediately when you look at a very bright screen, wow, you are just throwing a huge amount of light into your eyes. That is how you injured your retina. All right. I'm sure when you look at your parents' phone, this is how you feel, isn't it? Isn't it? I don't know whether your parents are like this. They will put their phone, if you look at their phones, the font will be ultra big, and then the volume will be at the max, brightness also at the max. All right. When I look at my mom's phone, it's like I'm staring at the sun. Okay. I seriously have no idea how y'all look at something with maximum brightness. My brightness is always close to the minimum one because my eyes cannot tahan one. Okay, so okay lah. This one you have to forgive them lah because once you start to get old your senses becomes less sensitive. Okay, your eyes become worse, your hearing become worse. That's why you need maximum stimulation. Yes, Ashwini, as you said. So they need maximum stimulation so that they can hear something. All right, so you can't blame them. But here's the thing, don't look at your bright screen in a dark room. It's not very good for your eyes. It's going to affect your sleep cycle. All right, because light actually reduces your melatonin, which is your sleep hormone. So it actually makes your sleep worse. All right. So anyway, G, explain how the eye controlling its size of pupil can prevent damage to the eye under high intensity of light. So there, I just said it just now. So if you have a lot of light, so how does it, what does it do? So your iris will decrease size of pupil. Okay, iris mengurangkan size pupil. Right, so this is to prevent excessive light from entering the eyes. To stop too much light going into your eyes, so they don't hurt your retina lah. Right, untuk mengelakkan cahaya berlebihan. Okay, memasuki mata. To stop it from entering the eyes. All right, so your iris is actually protecting you. Your pupil is protecting you. So suggest how you can protect your eye inside. Write this yourself lah. Do not rub your eyes. Okay, balanced diet. Do not stare at the screen for too long. Control the brightness of your phone. What else? You know lah. All right. Guys, eating carrot doesn't help. Looking at green plants doesn't help too. These are lies. Okay, freaking lies. Even if you eat like 10 carrots per day, nope, your eyesight is not going to get better. Okay, same goes to looking at plants. Nope, they're not getting better either. It's just a lie. All right, you write this yourself lah. I'm not gonna write. So anyway, again, you have your eyes. Okay, let's skip this question, shall we? Because this is eye question. Okay, let's skip ahead. Okay, let's go to our ear. Question number 9, shall we? Okay, let's look at question number 9. So name Q. Okay, Q is your ossicle. Whereas in BM it's called tulang ossicle. I don't know why. Okay, tulang ossicle. And then your function of the following part. What's the function of P? I'm just gonna say it here lah. So it's better to be in the dark than turn on the lights. It depends lah. It depends on the time. It depends on the time. During day, you need light to make you awake. All right. But during night time, anytime after evening, like 7 or 8, you should dim all the light in your house. All right, because if there's too much light, it actually affects your sleep. Okay. This is what the scientists say. 2 hours before your bed, there shouldn't be any strong light around you. That includes your phone. Okay, so it is best that you not look at your phone 2 hours before you sleep. But hey, that's just not possible, isn't it? Oh, let me check that Insta story just one more time. I'm guilty of it. Okay, I know I say it's bad, but I still do it too. Oops. Okay, anyway, so PRS, okay, I'll just say it here. I'm not gonna write. Okay, you can write this yourself. P is to vibrate. Okay, P is to vibrate according to the frequency of sound. Okay, bergetar mengikuti frequency suara, frequency bunyi. All right, so if my sound is high frequency, this one will vibrate high frequency lah. If my sound is low frequency, this one also vibrate low frequency. It follows the sound. All right, so for R, what's the function of R? This is to maintain body balance, mengekalkan keseimbangan badan. Whereas for your S, your cochlea, this is to convert or to change sound into nerve impulse. Menukarkan bunyi kepada impuls saraf. This is the thing that changes. It's like a translator, like I said. It translates your sound signal into an electric signal, and then they will send this to your brain. So your brain can interpret what the sound is. All right, ready yourself. I'm just too lazy. I'm just giving you the answer straight. Don't worry, the answer will be in your Google Classroom. You can check it later. So state the type of sense which helps structure R so that it can function perfectly. Now, what sense is this? This is sense of balance. All right, guys. I have to clear up something here. Deria keseimbangan. Many people say that, oh, we have only 5 senses. Okay, when you know something without knowing it first, it's called the 6th sense. That is actually false. We have like 8 or 9 senses. We have sense of balance. We have sense of space. We have sense of time. All right. So to say that we only have 5 senses, that is false. All right. Because when you are walking on a bridge, you know sense of balance. When you close your eyes and you talk, if let's say you are in a room, okay, you're blindfolded. When you talk, just by the echo, you can know roughly how big the room is. That's the sense of space. All right. So to say that you only have 5 senses, come on, your human body is much better than that. So that is false. All right. So C, range of sound frequency, you can hear from 20 hertz to 20,000. All right, and this thing will decrease as you age lah. So the hearing gets weaker because your eardrum becomes less elastic. Menjadi kurang kenyal. This is less elastic, so your hearing gets worse lah. So damaged cochlea cause deafness. How to overcome this problem? We have something called cochlear implant. Right, basically they put a thing inside your ear lah. So implant cochlea. Right, simple stuff. Next. This one, let's skip lah. Not involved in listening. That would be your eustachian tube, Eustacio, and your semicircular canal, salo separuh bulat. Right, one is for ear pressure, air pressure. One is for balancing. So let's go to question 11. Let's do the smell one. Okay, I'll try to cover as much as I can because it's a very long revision. So I explained how the smell of rose is detected by the brain. Okay, so first you can say the chemical substance. Remember, all smell and all taste is chemical substance. Okay, dissolves in mucus. Okay, bahan kimia melarut di dalam mucus. Alright, so what's next? Then they will stimulate your smell receptors. Okay, merangsangkan receptor bau. So it will send nerve impulse to brain. Okay, menghantarkan impuls saraf. Okay, ke otak. Alright, that's how your brain detects the smell lah. Alright guys, like I said, smell is a very subjective thing. There is no such thing as good smell and bad smell in this world. It all depends on individual. Okay, like I think I told you this before. For me, petrol smells great. Okay, when I go petrol station, oh, I love that smell. You might find me weird, okay? I don't care. I just love that petrol smell. Okay, so anyway, so state the location of your smell receptor. It is at the top of your nasal cavity. You know where's your nasal cavity? This is your rongga hidung. Okay, rongga hidung. So your nasal cavity is up here, the place where you have your mucus. Oh, same. Hey, high five. I don't know why, I just find petrol nice to smell. Hey, I'm not the weird one. My sister likes the longkang smell. She finds longkang smell nice. The one I cannot. Like I say, smell is a very subjective thing, okay? It's like, okay, it's like coriander. You know coriander? Some people, they like it, some people, they hate it. Okay? So, I'm the type of person when I eat steamboat, when I eat hot pot, I'm going to spam my hot pot with coriander. All right? But for some people, they say coriander tastes like soap. Okay? I don't know. I love it. I like my things to be flooded with coriander. That's the best smell ever. So C, the upper surface of nasal cavity is covered by mucus. Explain the function of the mucus when we smell. I think you can copy this two here. At the same point here. Okay, so that the chemical substance can dissolve in them so that they can stimulate smell receptor. It's the same point. All right, so next D1. Sarah's father is working in the paint factory. He smelled pungent paint. What are the risks faced by the father? He might damage his smell receptor. How can you protect your nose and the sense of smell? Wear a mask. Okay, wear a they call it the poison gas mask. Yeah, write this yourself. I'm not gonna go too much into this. All right, so if you need me to go back, you let me know. Please write increase your writing speed. Okay, I'm sure you are Form 3 already, so your writing speed should be okay. All right, so anyway, let's look at the next question. Okay, let's do one tongue one. So apple pie should be E because apple pie is sweet. Fried chicken should be B because it's salty. Salted fish is D. D is umami. Okay, this is umami. Because salted fish is, you put salted fish to make your porridge taste nicer, so that's umami. Dark chocolate is bitter, so A. Papaya pickle is sour, so this is C. Hey, this question looks familiar though. I think we've done this before. So B, during dinner, Siti's grandmother complained that the soup was tasteless. Siti felt the soup was salty. Both they did not have the flu. So why do these people taste different? All right, so like I said just now, as you age, your receptors become less sensitive, right? So you will need a stronger thing to make you feel, the certain taste, right? So why do these people taste differ? Okay, because you can say grandmother is older, okay, lebih tua. So you can say the taste receptor are less sensitive. Okay, kurang peka. This thing is not so good anymore. All right, so she would, you can say, weaker nerve impulse. Okay, weaker nerve impulse. Impulse saraf yang lebih lemah, or you can say she needs more salt to feel the same stimulus. Right? So this is something, guys, it goes for happiness as well. Have you noticed this? When you are young, you're like 3-4 years old, one candy makes you happy, really happy, right? Because that's the thing. A small thing makes you happy because you're still very sensitive to happiness. But nowadays, as we are very familiar with all these things, right? Do you feel happy if I give you a candy? You don't, right? Okay, if I give you a candy, if you score very well in exam, and your mom say, come, I'll give you a candy. You say, okay, you don't feel that happy because we are desensitized by all these strong stimulus already. Give you money. I like you, Ashwini. You're very realistic. Okay, very materialistic. That's how I like it. All right, so that's why I say, as you grow older, things become less and less sensitive to you. Right? So it will happen. It will happen. Next time, as you reach the age of 30 and 40, things just doesn't excite you that much anymore. All right. Imagine when you're a kid, when your dad says, let's go on a road trip, you say, oh my God, road trip. But by 30, by the age of 30, you ajak your friend go road trip, they'll say, okay, road trip. Yeah, you're still happy, but it's not as exciting as last time because you're desensitized by it. Okay, you're very sensitive to sadness. Oh, really? Then you have to address that problem. Okay, Jivika, you have to address that problem. Okay, so guys, why am I giving you a life lesson again? Okay, to be a happy person, you need to address happiness equally as your sadness. Okay, don't push your sadness away. Experience it, because only if you experience the sadness equally, you can experience happiness equally. Word of advice here, guys. Okay, happiness, being optimistic is not about pushing all your sadness away. It's about feeling them equally. They should coexist. Do you watch Inside Out? Do you watch Inside Out? You know the Pixar movie Inside Out? Okay, the more you try to create happiness, the more it doesn't happen. It's false happiness. But if you let sadness and happiness coexist, it creates a very sweet memory. Go watch Inside Out lah. You get what I mean. Wow, I can't believe I'm using a kids cartoon to to tell you about this. All right. Anyway, so the taste of food is better when served hot compared to cold. Explain this statement. All right. So you can say hot food. Okay, for hot food, the smell or the chemical substance, okay, spread faster in air. Okay, sebar lebih laju. Because hot stuff, they spread very quickly in air. That's why hot food, they stimulate your smell better. That's why you feel tasty lah. All right, so smell, they spread faster in air. So so they will stimulate smell receptor more. Okay, merangsangkan reseptor bau lebih kuat. Alright, so this is why guys, if you go to sushi I don't know about you sushi never makes me salivate. Okay, because sushi has no smell. But compared to a bowl of ramen, a hot bowl of ramen, wow, when I smell ramen that umami when it comes up, wow, I will start salivating. Okay, what about maybe Korean barbecue? Okay, if you go to Korean restaurant and the Korean barbecue, you can smell the hot barbecued meat. Oh, your saliva starts coming out compared to you eating sushi. Because sushi is cold, you don't really smell anything. That's the difference. All right. So anyway, let's go to plant question because we have done this already. Let's go to plants. I'll skip ahead Oh, let's talk about skin. We didn't do skin yet. Oh my god. Okay, so this is the proper diagram. This is the proper diagram, guys. Not that one. The one in your notes just now. The one is the lousy diagram. So you see, this is your pain receptor very clearly, followed by your touch. Touch is second because that's second most important, followed by your heat and cold. All right, how do you separate these two very easily? Can you see heat receptor? They kind of look like popcorn because popcorn is hot, right? So popcorn is heat. So the round one, this thing kind of look like popsicle. So this is cold. And then this one is your pressure. Okay, they are arranged according to importance. Pain is the most important because pain means danger. Okay, that's the most important thing for your body. So mark the factor that affects sensitivity. That would be your number of receptor and your thickness of epidermis. So what is our normal body? Why is body temperature here? This is homeostasis already, right? Oh wait, this is homeostasis already. This is in your form 1. This is in your form 1. So how do you regulate body temperature during hot days? I'm sure you remember this. P is your blood vessel. They will dilate. They will get closer to the skin so that they can dissipate more heat. Q, your hair will lie flat. Okay, whereas your R, they will produce sweat. Yeah, you learned this already. Okay, so anyway, let's skip ahead. Let's go to plants. Okay, let's go to question 16. Okay, page 20. So what is meant by positive tropism? Okay, that means growing towards the stimulus. Okay, tumbuh ke arah rangsangan. All right, if you're growing towards sunlight, sunlight is a stimulus, right? If you're growing towards it, that's a positive tropism. Okay, positive phototropism to me, in fact. So what happens after 5 days? Draw yourself the plant will come out of the hole here. So name the response. This is called positive phototropism. Right? Remember to put the word positive. Do not ignore this word. Many students, they will just write positive. Sorry, phototropism. Some teachers, they will give you right, but just in case, try to write the word positive. It makes your answer more complete. Okay, so B, Amin carried out an experiment to study the response of the root of a seedling to the stimulus of water. So this is a funny story here. Can you see the root is growing towards water, but not towards gravity, right? So this is a positive hydro, but a negative geo. Usually it's positive hydro, positive geo, right? Now it's for geo is the reverse because they're not moving towards geo. Because water is more important. So based on the result, how does the root respond to the stimulus of water? Okay, they grow towards water. Okay, tumbuh ke arah air. So why is the response important? This is to obtain water. Untuk mendapatkan air. Obtain water for what? For photosynthesis. Right, so why is it important for the shoot does not respond to the same way? Okay, because shoot needs to grow towards sunlight or towards up. Okay, need to grow upward. Okay, batang haruslah tumbuh ke arah cahaya matahari. This is to obtain sunlight. Okay, for photosynthesis. Okay, write this yourself lah. I'm not going to translate this lah. So what is that? What is meant by nestic response with nestic movement, right? This is a quick response from a plant when they are touched. I'm not going to write this. Write this yourself. Okay, I'm keeping everything short, guys. As you can see here, this Q is positive photo. P is positive geo. Okay, this is positive photo. This is positive geo. Okay, I'm keeping everything simple. All right, so anyway, let us just skip this part already lah. Let's go to chapter 2, shall we? We have done chapter 1 enough. Maybe if later we have the time, we might come back lah. Okay, I'm still not sure. So anyway, let's go back to our chapter 2, shall we? Let's go to page. What page is this? Oh, they didn't write the page here. So this is 1, 2, 3, 4, 5, 6, 7. Page 7. All right, so let's talk about our human respiratory system. Okay, this part very important for sure will come out in exam, so please listen. All right, so your lungs, there are certain parts that you need to memorize. So this is the same as your eyes actually. To memorize the important parts in your eyes, you just memorize the pathway of your light. Same goes to your ear. To memorize the important parts of your ear, you memorize the pathway of the sound. So same thing, to memorize the important parts of your lungs, you memorize the pathway of air, right? So what is the pathway of air? So you start with your nostril, okay, your nostril, and then it goes to your nasal cavity, which is here, nasal cavity, rongga hidung. Pharynx and larynx, this is not really important. I would not recommend you to memorize this. Pharynx is your throat, larynx is your voice box. Okay, the part where you produce sound when you speak. Okay, this is not important. And then it will go to your trachea, which is this thing here, the main pipe. And then they will split into two, which is bronchus. They spell almost the same as branches. So I just remember them as branches, bronchus. You see, the pronunciation is almost the same. And then they will branch into some more small bronchus, which is called bronchiole. Eole means small. Okay, tiny bronchus. Right, and then they will reach the final station, which is alveolus. And when your oxygen reaches alveolus, it's time to get into the next. It's time to transit. Okay, it's like the end of a bus station already. It's time for you to transit to another place. So your oxygen will jump into your blood vessel, as you know. Jump into blood vessel for what? Go to your red blood cell. Your red blood cell will collect the oxygen, and they will go around your body. They will distribute the oxygen. You know this, right? Okay, you learned this in your chapter 3 as well. All right, so if you look at this lungs part here, you don't need to memorize the larynx and the pharynx. Epiglottis is also not very important. So nostril, nasal cavity, trachea, bronchus, bronchiole, and alveolus. Left lung, right lung, I don't think I need to tell you this. Okay, what about these two muscles? Okay, do take note, guys. These parts they don't move. All right, I'll say this again. These parts, they don't move. If they can't move, how are you supposed to inhale and exhale? Right? Because these things they are just pipes. They cannot move. So how do you move them? That's when your muscles come in. These two muscles, okay, I'll use another color. This intercostal muscle and your diaphragm. So these two muscles, their job is just to do inhalation and exhalation. Their job is to move your lungs. Since these things, they can't move, right? These 6 parts here, cancel away these 2 6 parts here, they can't move. The only part that is moving when you are breathing, it's these 2. Okay, your intercostal muscle and your diaphragm. So where is your intercostal muscle? Intercostal muscle is between your ribs. Okay, you guys got eat pork? You guys got eat bak kut teh? Or you guys got eat lamb ribs? Okay, when you're eating ribs, I don't care whether you are eating pork ribs or lamb ribs or cow ribs or whatever ribs you are eating, you're basically eating this muscle. Okay, when you eat bak kut teh, you eat the pai guat, which is the bones of the pig here. You are eating this muscle basically. So diaphragm is this thing at the bottom of your lungs. Okay, this is where they push your lungs and pull your lungs during inhalation and exhalation. All right, so let's talk about inhalation and exhalation, shall we? All right, so like I said just now, you just memorize one side, the other side is the total opposite. Very simple. So what happens when you inhale? When you tarik nafas, you're trying to pull air in, so all your muscles will contract. You see, when your muscles contract, they pull air in. They pull, so they contract. So your intercostal muscle, they will contract. That means, okay, these are your ribs, your rib bones. So when they contract, they will pull your ribs up. Can you see? They pull your ribs up. So when they pull it up, your rib cage, they will go upward and outward, going out and up. That's why when you inhale, your chest goes, you see, out and out. So, and then your diaphragm muscle, they will also contract, okay, which is here. So now, since this part also contract, this part also contract, now your lungs become bigger. The volume is bigger. Okay, the volume is bigger. The thoracic cavity now is bigger. What is your thoracic cavity? Thoracic means your chest. That means your chest cavity. Why don't they just call it chest cavity? Am I right? No, because chest doesn't sound scientific, so they call it thoracic cavity. So they become bigger. All right, so the pressure will decrease. All right, so I think you learned this before. When volume increase, pressure decrease. You learned this in Form 2, right? In that pressure chapter. When you make something bigger, okay, when you make a balloon bigger, inside has less air, it is less crowded, so the pressure decrease. All right, so when the pressure decrease, inside has lower pressure, outside has higher pressure, the air will be pushed into your lungs. So this is inhalation. So exhalation is the total opposite. So your muscle, they will relax. Your rib cage will move downward and inward. That means down and in, like that. All right, and then your muscle will relax. Okay, this diaphragm muscle will relax. So now your volume will decrease. Your lungs become smaller, so the pressure becomes higher. So inside higher pressure, outside lower pressure, your air will be pushed out. Remember, pressure always goes from high to low, never the other way around. Always high to low. It's like humans lah. We will tend to travel from crowded place to a less crowded place. Right? If it makes any sense. Okay. So now the thoracic cavity is smaller, pressure increase, so you push the air out. Right? As simple as that. So you just memorize the one side, the other side is the total opposite. Okay. And one more thing, you have to memorize this diagram. Not to say memorize, you have to know lah. So what does this part represent? Okay, the glass tube, it represents the trachea, the Y tube represents the bronchus, balloon represents the lungs, the jar represents your chest cavity, thoracic cavity, and the plastic sheet represents your diaphragm. Now this part, I don't know, for some reason, they love asking this in exam, which is a good thing. This is very easy to understand. Okay, anyway, so this percentage of oxygen in the air, it's not mentioned here, but you can write this down. The air you inhale, oxygen is 21%. Okay, you inhale 21% oxygen into you because around you is 21% oxygen. You learned this in Form 1. All right, so when you exhale, it's 16%. Your body doesn't fully absorb all the oxygen. They just absorb like 4-5% of it. And as for carbon dioxide, okay, carbon dioxide, I'm going to write CO2 here. When you inhale, it's 0.03. Because as you know, around us, we have 0.03% of carbon dioxide. And when you exhale, it's going to be 4%. All right, so as you can see, carbon dioxide increase and oxygen decrease. That means we are using oxygen, we are giving out carbon dioxide. So this is what we call gaseous exchange. All right. So anyway, moving on, let's talk about our alveolus. Okay, this is the most important part of this chapter. I've said this many times and I will say this again. This is the part that you have to memorize. So what is this? This is your alveolus. That is your alveolus. This is your blood capillary. Your blood capillary. You have deoxygenated blood here. You have oxygenated blood here. So oxygen will jump into your blood, carbon dioxide will jump out from your blood. Okay, you know this lah. So you have high concentration of oxygen here, low concentration of oxygen here. That's why they jump into your blood. And then you have low concentration of carbon dioxide here, high concentration of carbon dioxide here. That's why your carbon dioxide will jump out. This is the same as pressure. You will always go from high concentration to low concentration. Okay, you see? High concentration to low, jump out. High concentration to low, jump in. All right, so this is how your blood turns from deoxygenated to oxygenated. Darah terdeoksigen kepada darah beroksigen. So this one you know lah. So how do they do this? The process, by the way, is called diffusion. Okay, resapan. Very important, resapan. And then they do this using something in your red blood cell called hemoglobin. Remember what is this? Inside your red blood cell, there's this red color protein called hemoglobin. They really like oxygen. Okay, they really like oxygen. So this hemoglobin, they will combine with oxygen to form something called oxyhemoglobin. You know this also. And this oxyhemoglobin, they are not very stable. Once they are at your body cells, they will disintegrate, they will break into half. So this oxygen, they will give it to your body cell. All right, which is a good thing. And then what does your body cell do? They use your oxygen and do respiration. Hey guys, you learned this in Form 1. Glucose plus oxygen, you get carbon dioxide, water, and energy. Don't tell me you don't know this. I'm gonna slap you. Okay, you learned this in Form 1. Okay, for God's sake. All right, so this will be your hemoglobin. So hemoglobin, as you can see, is very important. Okay, anyway, so importance of the adaptation of the alveolar structure. Okay, this part also very important. Your alveolus has 4 characteristics, making them very efficient in doing gaseous exchange. Okay, so they are, number 1, they are thin. Okay, number 2, they are moist. Okay, you can say they are one cell thick also lah, setebal, satu cell. Moist, okay, lembab, they have large surface area, they have a network of capillaries. So 4 characteristics. All right, this is the same as your villus actually. Remember, you learn your villus in your Form 2 chapter 3, right? That digestion chapter, right? So your villus has the same 4 characteristics. What is villus again? Villus is this finger-looking thing in your small intestine that helps you absorb food, remember? Okay, so how do they absorb food? Well, again, the 4 characteristics. They are thin, so that they can absorb food faster. Moist, they have large surface area, that's why they are folded. And then they have a large network of capillary. You have capillaries inside your villus, that's why they can absorb food very well. So this is the same as alveolus, guys. This is the same. Even the name is the same, okay? Lus and lus, villus, alveolus. So 4 characteristics. You have to memorize it because these 4 characteristics, we will use it to describe animals. Okay, let's talk about the animals lah. So for frog, they have the same characteristic as us. They are thin, they are moist, they have network of capillaries. You see, same. For fish, they have many filaments, so large surface area. They are surrounded by water, so moist. Okay, you can even say that they are thin because you see your gills, you have all these tiny lamella here. These are thin. So 3 characteristics here. They didn't even mention blood capillary though. Okay, you can even say they have blood capillaries. So all 4 characteristics that we have, fish they have it too. So for insects, same thing. They are thin, they are moist, large surface area. Do not write blood capillaries here, guys. I think I told you this in normal class already. Do not write blood capillaries for insects because insects have no blood. Okay, insects, they don't use blood. So don't write blood capillaries. It doesn't apply to them. But what I'm trying to say here is the 4 characteristics that we have to exchange gas, animals and insects, they have it too. All right, every living organism, they have these characteristics to help them absorb gas better. Okay, that is just adaptation. Okay, easy. So anyway, let's talk about some of the K-Bud stuff lah. So what are the harmful substances to your respiratory system? Of course, you have your cigarette tar, they're going to give you cancer. carbon monoxide. Okay, please memorize this. Carbon monoxide, okay, just now, oxygen and hemoglobin, they are unstable. That means they can break away anytime. So your hemoglobin is free to carry another oxygen. But carbon monoxide is different. Carbon monoxide and hemoglobin, they form a very stable compound called carboxyhemoglobin. This thing, they will not break away. That means your carbon monoxide will clamp onto that carbon, your hemoglobin forever. They will cling onto it forever. So now your hemoglobin cannot carry oxygen. The oxygen just stands there. Hey bro, when are you going to carry me? It's like a bus is fully occupied always. So as you absorb more and more carbon monoxide, you're going to get something called carbon monoxide poisoning. That's when your red blood cell is fully occupied by carbon monoxide to a point that you cannot carry oxygen. Okay, so if you cannot carry oxygen, then you die lah. Okay, you will have lack of oxygen. So sulfur dioxide and nitrogen dioxide, these are acidic gases. You know lah, these two, they will form your acid rain. You learn this in geography. So if they are in our lungs, they will corrode our lung tissue because they are acidic. All right, so haze, dust, and pollen, this one will trigger asthma. If you're allergic to it, like me, I'm very allergic to dust. Fortunately, I don't have asthma. But if you do, let's say if you have asthma and then you are easily triggered by pollen, then that's a very bad thing to happen. Okay, so anyway, moving on. Let's go to our diseases. Okay, this one I think I mentioned in class already. Asthma is when your bronchiole suddenly closes. Bronchitis and emphysema and lung cancer, these three, they are mostly caused by cigarette. Okay, they are mostly caused by cigarette. So if you have, if you smoke a lot, then you might get these diseases. Okay, anyway, so next is your cigarette. What will they cause? Please draw one thermometer here. They didn't draw it here. So this experiment shows us that cigarette has three effects. Number one, it increases your temperature in your lungs. Number two, it blackens the lung. Okay. Number three, it is acidic. This thing will change color. It will make it acidic. So these three characteristics shows that cigarette has three side effects to our lung. Okay, it makes our lung hotter. Okay, hotter is a bad thing because when your lungs are hot, they absorb gas less efficient. Okay, and then it blackens your lungs. Okay, and then it makes your lungs more acidic. So these three, you have to memorize them. Okay, and then the animals one, you've gone through it already. Adaptation. This one, I think I've mentioned plenty of times in class already. So at high altitude, okay, when you lack oxygen, your breathing rate and your heart rate increase. This is to compensate for the lack of oxygen. Same goes to when you're exercising. When you're exercising, you also lack oxygen. Okay, so when you lack oxygen, what do? You breathe faster, your heart rate also faster. Again, to compensate for the lack of oxygen. Same goes to diseases. If you have anemia and sickle cell disease, you also lack oxygen. Okay, anemia is when you don't have enough red blood cell. Sickle cell is when your red blood cell is abnormal. Okay, they look like a sickle shape. So both of these cases, you lack oxygen. So again, you will have higher heart rate and you have higher blood pressure and breathing rate. So all these three, they are trying to tell you that if you lack oxygen, whether it's due to your altitude, you're at a high mountain, whether you are exercising, whether you have a certain diseases, your body will try to catch up by doing something, by beating the heart faster, by breathing faster, okay, and so on. Your body will adjust accordingly. Okay, so anyway, plants one, I will not talk too much about this. This is really simple. Plant, they just do gaseous exchange by opening a hole at the bottom, which is called a stoma. Yes, this is very boring, I know. This is your stoma. So during daytime, they open the stoma for what? To do gaseous exchange, to absorb carbon dioxide, to throw out oxygen. Okay, because oxygen is what they don't want. Carbon dioxide is what they want to make glucose. So how do they open it during the day? During daytime, they will absorb water. Okay, they will absorb water. This process is called osmosis. Okay, osmosis. They will use osmosis to absorb water. Okay, and then the cell will become turgid. Okay, turgid means full, penuh. Okay, I think in BM it's called segar. They look very full, so they will swell. When they swell, they will curve outward. When they curve outward, they open. All right. And then at night, they lose water. Now they become flaccid. Okay, flaccid is I think it's mandata. Is it called mandata? So they become flaccid, they become flat lah. So they will close the hole. Okay, so by the way, these are called guard cells. These are called guard cells. Okay, cell pengawal. Stoma is the hole. The lubang is the stoma. Do not get confused here. All right, nothing much to say here. I know this is very boring. So I'm going to skip this ahead lah. Okay, let's go to our exercise. Okay, let's go to our exercise. Hopefully you're still with me. I know it's a very long Sunday. Okay, let's jump to our exercise again. Let's go to page 27. My muscles hurt from writing. Okay, because it's been a week. I had an awesome holiday. I hope you guys had your awesome holiday too. So I haven't write for like 1 week already. So my muscle kind of hurt from writing. Okay, anyway, so question 1, you have your X and Y. So X would be your trachea. And Y would be your diaphragm. Okay, bronchus is actually here. Okay, hang on. Let me see who's here today. I haven't seen the name list. Oh, hey, Cecilia, I haven't seen you in a while. How are you? I always don't see you in class. Okay. Oh, I only noticed you here now. Oh, sorry. Okay. Hey, Jolene, I think I haven't seen you in a while too. Wow, some familiar names today. Oh, okay. I haven't seen you guys. And Yushen, hello. Sorry, today too rush already. Yes, Jolene, how are you? The last time I saw you, you were in Form 1. Oh, crazy, man. You're having exam last week. Hey, Cecilia, you having exam? Are you taking the IG one or are you taking the SMK one? Or are you doing both? Are you doing both? Oh, you're doing both. Okay. That's cool. Okay, anyway, haven't seen you in a while because usually I see you on Tuesday, right? Usually it's on a Tuesday. Oh my God, guys, you guys grow up too quickly already lah. Some of you, I see you all. The last time I see you all, you guys are in Form 1. Wow, goodness me, now you're in Form 3 already. Oh my God, you guys need to slow down. Okay, next, number B. So mark for the correct statement about the gaseous exchange at the alveolus. So when you do gaseous exchange, concentration of oxygen is lower in the alveolus than in the blood capillary. No, it's actually higher. So this is wrong. Because only when the alveolus is higher, like here, where was it? Yeah, here. Okay, only when it is higher here and lower here, only they can diffuse. Diffusion, resapan, 渗透. Okay, this is in Mandarin. Okay, anyway, number 2, the transport of oxygen across the surface of alveolus is called diffusion. Yes. Okay, resapan. The wall of alveolus is 1 cell thick. Yes, it is. Okay, so number 4, oxygen combines with hemoglobin when reaches body cell. No, it actually separates with the oxygen. So no, this is wrong because I need to give body cell the oxygen. Right? I think I told you this, guys. Your alveolus, your total surface area of your alveolus is as wide as a tennis court. You have a tennis court of alveolus inside your lungs. All right? And if you exercise more, if you're a person who loves exercising, this area can get even bigger. Okay, let's say you are an Olympic cyclist. Your alveolus, you will grow more alveolus and you will grow more blood vessels. That means you increase your stamina. All right. On the other hand, if you smoke, you're going to kill your alveolus and you're going to kill your blood vessel. That's why your stamina gets worse. You go and ask those smokers to run and see. You ask those long-term smoker, that means they have been smoking for 20 years. You ask them and run and see, their stamina will suck because, well, not unsurprisingly, because they've been putting so much rubbish in their lungs. So Diagram 3 shows gaseous exchange the process. So complete the box below. So this, what is jumping into your blood, that would be your oxygen. And then what is this thing? This is your red blood cell. All right, the jumping out one, this is your carbon dioxide. Okay, no white blood cell here. Okay, no white blood cell. Okay, how can you have white blood cell here? So next, B. Oxygen is transported in human blood in an unstable compound called oxyhemoglobin. All right. So another quick thing to let you know, hemoglobin is made from iron. Okay, iron. That's why your blood smells like iron, because iron loves oxygen. That's why when iron see oxygen, they will pull the oxygen in. That's why you have oxyhemoglobin. All right. So number 2, what is a harmful gas which reduces transportation of oxygen in human blood? That's your carbon monoxide. This is how some people committed suicide by burning charcoal. If you close yourself in a room and you keep burning charcoal, you will die because you get carbon monoxide poisoning. All right, or you can use the car exhaust thing. Okay, you link the car exhaust back into your car, you get carbon monoxide, that's how you die. All right, so number 3, diagram 3 shows the respiratory system of a human. So this would be your trachea. Number 2 would be your lung. Okay, I'm not writing, sorry, I'm just lazy. So B, fill in the blanks to complete the statement below. During inhalation, the diaphragm contracts. Okay, mengecut. Always remember, when you are inhaling, you are trying to pull air in. When you try to pull air, you contract. Okay, you pull it in, you contract. Only when you relax, you push the air out. Very easy to understand. So number 2, during exhalation, air pressure inside the lungs increase. Okay, meningkat. Because I'm trying to push air out of the lungs, that's why they increase. Okay, next, number 4. Some of the chemical substances are harmful to the human respiratory system. So mark the harmful substance. That would be your carbon monoxide and your sulfur dioxide. Nitrogen is no harm. This is 78%. Okay, if you still remember in your Form 1, you have 78% of nitrogen in the air. You just suck them into your lungs and you just throw them out. They will do nothing. Okay, they just go into your lungs sort of like a road trip, and then they come back out as nothing. Like that. So that's your carbon monoxide and sulfur dioxide. So carcinogen and nicotine are harmful substances in your cigarette smoke, match, eats chemical substance which is effect. Okay, so what is carcinogen? Carcinogen is anything that causes cancer. All right, like I'm sure your mom tells you when you eat satay, do not eat the black charred part, the part that is burned. Don't eat, because that part is a carcinogen, because it causes you cancer. Cigarette smoke contains a lot of carcinogen. Okay, why? Because your cigarette smoke has tar. All right. Fun fact, guys. Fun fact, your cigarette has one more thing called polonium. This thing is a radioactive substance. Do you know cigarette is radioactive? Okay, you will learn this in Form 3, Chapter 6, I think. Cigarette is very radioactive. That means you are putting radiation into your lungs. Do you know that? Okay, 1 pack of cigarette. Okay, fun fact, guys. 1 pack of cigarette is equal to you getting 50 X-rays. 50, as in 50. Would you go and get 50 X-rays? No. But if you smoke 1 pack of cigarette, it's equal to 50 X-rays. Hey, 1 pack of cigarette is nothing, compared. If I don't know whether you have seen smokers before. If you are not a very strong smoker, you smoke occasionally, you smoke like 1 pack in 3 days. But for frequent smokers, okay, they will smoke 1 pack per day. That means their lungs will get the radiation of 50 X-rays per day. How can you not die? You see, how can you not die? So people who smoke, they are putting so much polonium into their lungs are all radioactive. That's how they get cancer. So people who smoke, they have no rights to complain about radioactive. Okay, I actually have a friend last time who said he smokes, okay? I have a friend who smokes. He say, oh, I don't switch on my Wi-Fi at night because Wi-Fi has radiation. I was like, huh? Wi-Fi gives you radiation. Why don't you stop smoking? You see, this is a very stupid thing to say. Hey, even if you hug your modem to sleep, okay, who would do that? But let's say you hug your modem to sleep, you won't die. Okay, I've never heard of people who get cancer because of Wi-Fi. That just sounds stupid. But yes, I've heard plenty of cases of lung cancer because of cigarette. So the radiation is already in. Yeah, exactly. So people who smoke, they have no rights to complain about radiation. I mean, guys, for me, I just think smokers, they are the most selfish people in the world. They are the most selfish people in the world because not only they smoke to harm their health, they are also giving out secondhand smoke to harm your health. So stop trying to tell me, oh, sir, smokers, they're not that bad. Yes, they're bad. They're selfish people. Why else would they smoke? Okay, you are burning away your money. You are burning away your health. It makes zero sense. Okay, anyway, so nicotine, this thing gives you addiction. All right, so what is nicotine? Nicotine is the thing that makes you awake, kind of like caffeine. Okay, the thing that is inside your coffee. So this is why they are addicted to smoking, because once they smoke, it gives them the high, the short momentary high, which makes them awake and alive. That's because of the nicotine lah. So this is what the concept of vaping is about lah. Okay, they say vaping is supposed to be healthier because they just extract the nicotine from the cigarette and then they just put it in some kind of vegetable oil, and then they just use electric and heat this thing up. You're not smoking any of these polonium and tar, you're just smoking the nicotine. It's supposed to be healthier, but is it though? No. No, okay, vaping is no better because only lately they found out when you smoke this, when you vape, when you smoke the vegetable oil that they put the nicotine in, when you smoke that heated, because when you vape, they actually heat the vegetable oil and it becomes vapor. So when you heat the vegetable oil, it actually turns into another type of carcinogen, another type of cancer-causing agent. So in the end, you end up at the same place. All right. So if you ask me, sir, is vaping better or smoking better? Both are not good. Okay, let me ask you, is cow shit better to eat or horse shit better to eat? Why would you eat both? Okay, so it's the equivalent. Is vaping better or smoking better? Well, if you have to choose, vaping, I guess. Hey, not to mention, guys, vaping has a chance of the thing exploding in your face. You know, vaping has a battery, right? The vape machine has a battery, right? And there are cases of that battery going haywire and the thing explode in the smoker's face. Hey, you die immediately. You die faster than you smoking. Okay, so is it any better? I don't know. So, moral of the story, do not smoke. Okay, they are not cool. I don't get what's the point of, oh, some people they smoke because they think it's cool. No, it's gay. Smoking is gay. Okay, how does it look cool? Okay, anyway, so number 5, write true or false in the boxes below. So the external intercostal, okay, you can just ignore the external. Okay, intercostal muscle contract and pull the rib cage up. So you are exhaling, right? When you are exhaling, do you pull your rib cage up? No. So this is false. So the intercostal muscle relax and lower the rib cage. Okay, this is correct. Because you're exhaling, what you are doing, see, it goes down. All right. So number 3, the diaphragm muscle contract and diaphragm curves upward. Yes, this is the way. Oh no, contract is wrong. So this is false. Okay, because it is supposed to push things out. It is supposed to relax, not contract. All right, so this is false. Next, B, match the following harmful chemical in cigarette smoke to their correct effect on health. Hey, this is the same thing. Nicotine, they cause addiction. All right, so tar, they will kill your cell. Okay, and then you see they cause cancer. This is your carcinogen lah. Okay. Guys, do you know what else is a carcinogen? Preserved meat. You know, it's preserved meat. Any meat that is preserved, okay, not fresh meat lah. Basically, your burger meat, your sausages, your hams, your bacons. Okay, these things they are carcinogens too. It's already certified by the World Health Organization. These preserved meat they are going to give you cancer. Okay, so don't eat so much burger or sausage or hams or bacons. Yes, they're delicious, I know, but they are classified as a carcinogen. Okay, I mean, come on, nowadays everything is carcinogen, isn't it? Everything they say will give you cancer. All right, so anyway, this is almost a similar question, isn't it? Let us skip lah. Let's skip this question. Let's go to question. Hey, this is the same also. Let's go to question 8. Okay, let's go to question 8. Oh, this looks like a funny question. So your blood is from your heart here. It goes to your lungs to collect oxygen, and then it goes back to your heart. So, they want you to label PQR. All right, so what is P? What is the blood vessel that goes from your heart to your lungs? This is actually chapter 3. This is your pulmonary artery. What is this thing here? This is, like I said, your lungs and your heart these two chapters, they are kind of linked together. So there's a pulmonary artery. In BM, it's called artery pulmonary. Okay, and then your Q is your blood capillary. Capillaries. Okay, capillary dara. And then your R, this is your pulmonary vein. Okay, vena pulmonary. All right, like I told you, artery is anything that exits the heart. Okay, see, I exit from the heart to the lungs, so it's artery law. When I go back to the heart, anything that goes back to the heart, it's called vein. This is chapter 3. So explain the effect of iron deficiency in one's diet. I just told you just now. Okay, so the body is unable to produce hemoglobin. All right, so when you don't have enough hemoglobin, you will lack oxygen. Okay, you will lack oxygen. Okay, so make sure you eat enough iron. You eat enough iron. I mean, if you eat red meat and green vegetable as in dark green leafy vegetable, like your bok choy like any dark green vegetable broccoli, you will get enough iron. They have iron inside, so make sure your diet is in balance, then you'll be fine. Okay, you don't need to purposefully go and eat iron supplements. That's not needed. So diagram 7.2 shows the relationship between blood capillary and blood cell. So I think this is chapter 3 also. Difference between cell Y and cell X. So X is a red blood cell. You can say X is X has no nucleus. Y has nucleus. All right, your white blood cell always have nucleus. As you can see the inside here, red blood cell has no nucleus. Okay, what else can you say? The function is different. Okay, X carries oxygen. Y fights pathogen. They are different function. Okay, your red blood cell will carry oxygen to you, whereas your white blood cell, they will fight any foreign substance for you. So there are two different things. Hey, this is chapter 3 lah. How is this chapter 2? Okay, nutrient required for formation of hemoglobin, iron lah. Told you this already. So match the following animals with their respiratory system. So ikan siakap, this is your gills. Mosquito is trachea. Okay, insect they use trachea like us. Okay, it's called a tracheal system. Frog they use moist skin. In water, but when they are on land, they use gills. They use lungs like us as well. All right, so hey, this familiar question again. So what happened when the rubber sheet is pulled downward? When I pull this down, so what happened? This volume inside increases, isn't it? Pressure decreases inside, isn't it? So the volume of bell jar increase, isi padu serkup kaca meningkat. So pressure decrease, okay, tekanan menurun, so air enters the balloons. Okay, udara memasuki balloon. Because the pressure here is low, outside pressure is high, so the pressure will try to enter here. Like I said, pressure always go from high to low. This is in your form 2. So number 2, state one disadvantage of the bell jar as compared to the rib cage. Okay, so compared to your ribs, what's the disadvantage of this? Bell jar, they cannot move. Okay, they cannot move freely. Okay, tidak dapat bergerak bebas. Right, your rib cage, they have muscles to move them. Okay, so one disadvantage. There's only one mark here. What do they give 2 leh? Okay, so you can say rib cage can be moved by intercostal muscles. Okay, boleh digerakkan oleh otot intercostal. So this thing can move your ribs. Okay, your ribs, they are free moving because they are bones. Okay, they are bones and then they are attached by your muscles. Whereas this jar is glass. Glass cannot move. So that's the bad thing lah. So next, C, percentage of carbon dioxide and oxygen in inhaled air. So value of X and Y. X is going to be 4%. Y is going to be 16%. I told you this already in the notes just now. Okay, so next, question 10. So what is represented by P and Q? P would be your pharynx. Like I said, this part is not very important. Don't want to memorize also, never mind. Q is your bronchus. All right. So okay, guys, when you have your sore throat, it's your pharynx that is swollen. All right. But sometimes when your sore throat gets worse, to a point that you cannot talk, because the thing kind of moves down. The thing swells downward until your larynx also swollen. Then you cannot talk, lor. But usually that's not the case, isn't it? Usually your sore throat only happens for like what, 2-3 days. So your pharynx is swollen. But before this thing can spread to your larynx, you are recovered. So you are okay lah. So that's the thing, lor. So B, so this is an alveolus. One adaptation which increase the efficiency. You have 4 here. They are thin, moist. What else? Large surface area. You have your blood capillary. Okay, nipis, lembab, luas permukaan yang besar, diseliputi oleh kapilari darah. So 4 characteristics, same as your villus. Very important. This one will almost for sure come out in exam. So one example of respiratory disease, asthma. So cigarette smoke contains carbon monoxide that can cause death. Explain. So carbon monoxide, okay, forms carboxyhemoglobin. All right, so they are very stable. So hemoglobin are unable to transport oxygen. Okay, membentuk carboxyhemoglobin sangat stabil. Okay, tidak dapat mengangkut oxygen. Right, so you cannot carry oxygen. That's why you have a lack of oxygen in your body lah. All right, so can you imagine this? If you constantly smoke, you constantly put carbon monoxide in your body, you constantly produce carboxyhemoglobin, you are constantly lack of oxygen. So like I said, when you lack oxygen, what will your body do? Your heart will beat faster, you will breathe faster. Your body is trying to compensate for this. Like I told you, if you're at a very high mountain, if you are exercising, if you have anemia, these three conditions, they will cause you to have a lack of oxygen. So your body will try to compensate by beating the heart faster and try to breathe faster. So if you smoke, okay, you will force your heart to work harder. So this is why people who smoke for years, they will get heart disease. Okay, you might say, sir, smoking only affects the lungs, what? How does it do with what does it have to do with the heart? Because you make your blood lack oxygen, then your heart needs to pump faster. So indirectly, you are making your heart work faster lah. So this is how you damage your heart lor. Okay, if you overwork your heart, that's not a good thing to happen because your heart will fail sooner or later. So D, this is your tracheal system of grasshopper. So grasshopper, they absorb their oxygen using this hole here called your spiracle. And then this is the trachea. They don't have bronchus. They have something called tracheal. This is their muscle. All right, so they directly absorb oxygen to their muscle. They don't use blood. They don't use blood because they're small. They don't need blood. So explain to adaptation. Like I told you, they are thin, they are moist, they have large surface area. Do not write blood capillary because grasshoppers, they do not have blood. No blood. Don't write blood capillary here, that's wrong. Okay, so anyway, just choose two lah. Okay, thin and moist always apply for any animal or insect. So anyway, they got no plant question here. Never mind, then we do one more 11 lah. So shows the content of oxygen and carbon dioxide in inhale and exhale air. So this one I showed you just now already. Explain the difference in the content of two types of air. Okay, so number one, oxygen decreased. Okay, because it is absorbed. Okay, menurun kerana diserap. So carbon dioxide increased because it is given out. Okay, meningkat kerana disingkirkan. Okay, they are thrown out, that's why they increase. Like here lah, you see from 0.03 to 4, they increase. 21 to 16, they decrease. All right, so this is your alveolus. Okay, this is your alveolus. Explain the exchange of gas in the alveolus. So you have a high concentration of oxygen in alveolus, low oxygen in blood capillary. Okay, so carbon dioxide, low in alveolus. Okay, high in blood capillary. So you have gaseous exchange. Okay, pertukaran gas. Okay, sorry, my answer is a bit long. Okay, but they are asking for both gases, so I have to explain both. All right, you can even say diffusion here. I would accept also. I'll give you 1 mark. Resapan. As you know, these are keywords. The words I ask you to write, I keep asking you to highlight. Those are keywords because you have to include them in your answer. So explain the transfer of oxygen after the exchange of gas. Okay, so they combine with hemoglobin. Right, they'll form something called oxyhemoglobin. Right, so what happens next? They are pumped. They are pumped to body cells. Okay, oxygen is given to body cells. Okay, don't need to explain long lah. It's only 2 marks here. Diffusion is gaseous exchange. Gaseous exchange is the exchange of gas like that. Oxygen and carbon dioxide going different way. That's exchange. Okay, so gaseous exchange is two diffusions, I would say. You see, oxygen diffuse out. Oh, sorry, diffuse in. Carbon dioxide diffuse out. So these two diffusions, they are called gaseous exchange because these two diffusions, they happen together. So you cannot just say diffusion is gaseous exchange. I would say these two diffusions, they become gaseous exchange. I hope I make sense. Okay. So anyway, so let's do one more. So a person who inhales too much carbon monoxide may die. Explain this yourself lah. Carboxyhemoglobin reduces oxygen in the body, so you die lah. So one effect of dust on the respiratory system causes allergy, causes asthma attack. One way to reduce inhalation of dust, you can breathe using your nose, avoid dirty areas, use air purifier. Okay, so many things you can do. Okay, anyway, you know what? I think I'm going to stop here. Oh, that will be all for our questions. So if you need the answer, I will put it in our Google Classroom. You can check it there. You can check the answer there. In case you want to finish, okay, you can go home and do the objective question and check your answer. That's the least you can do because it's easy, right? If you really want to revise for your exam. So maybe, let's say tomorrow is your science exam, you can do the objective question today before you go for the exam. It kind of acts like a reminder, a quick revision for you. Okay, guys, I hope this revision is helpful for you. Okay, helpful for your first exam. Thanks for coming. Okay, happy Sunday to you all. I will see you guys, some of you guys in physical class next week lah. All right, objective so small. That's the best we can fit it. All right, so happy Sunday to you all. Okay, have a happy school reopening tomorrow. I will see you again. All right, so thank you guys. See you. Okay, good night and bye-bye.